Boom. Hello and welcome back to Calculus 1 Exam 2 review. You see my moods. My mood swing right away, right? So Exam 2 is on Chapter 3. It's next Saturday, so be here. Your quizzes start tomorrow morning, 6 a.m. Sunday. You are looking for Exam 2 Quiz 1. They open, close each day. Go have fun. Focusing on Chapter 3. Again, 10 problems. And whether I'm going to have the one in the back or not, that depends on the level of spice of the exam. It's Chapter 3, so we have to go back and think about these things. If I am to pick, what are my, not personal favorites, but what are the most important things of Chapter 3, we have to be realistic and say, well, obviously, related rates, obviously, tangent line problems. So if I'm to write anything in red, that's going to be related rates, tangent line problems. Now we know that related rates utilize implicit differentiation, but the tangent line problem in that derivative can have anything, right? Anything. And the entire. So now, also, we can add in red differentiation techniques, So what do we have under differentiation techniques? I'll put a little plus over here. We have basic derivatives. Now, that's all the basic rules that you just memorize. Derivative e to the x is e to the x. Derivative of a polynomial is n x to the n minus 1. Derivative of sine is cosine. It's all basic. Then we have product rule. Then we have the quotient rule. Then we have the chain rule. Then we have implicit differentiation, our favorite. And logarithmic. All of the trig stuff, inverse trig stuff, polynomial, e to the x, ln x, all of that belongs to the basic derivatives. So, basic derivatives, polynomials, exponential, log, trig, so all basic ones are under basic.
And obviously this stuff needs to be memorized, right?
Yeah, you know all of these formulas already, right? So you just write it out. And then we have something else was there. Oh, limit definition of the derivative. 3.1. Limit definition of the derivative. And that's your good old limit h goes to 0, f of x plus h minus f of x divided by h. So that one is there. We had continuity, right? No, continuity was in the previous one. What else was there? There was one more thing. The derivatives at rate of change. You know what that is. Position, velocity, and acceleration. There you go. What have I just listed? Entire chapter 3. What did I skip? Nothing. That's the entire chapter. 11 sections. That's the longest chapter in calculus book. I mean by number of sections. Chapter 11 is longer. Calculus 3 has 9 sections of the problem. And why do I have these 3 things in red? Well, first off, related rates, that's the word problem. Remember, you're getting money if you know that stuff. Why is the tangent line there? Tangent line is the most important problem of chapter 3, and tangent line is one of the most important things in all of the calculus. Tangent line, its slope measures instantaneous rate of change at a point. When you are looking at your speed, the number that you are reading on your speedometer as you're getting pulled over is the value of the derivative, the slope of the tangent line, that number. So if you glance on it and you see 82, the slope is 82x plus whatever b is, okay? So that 82 is the slope. Tangent line problems can be calculated for every section of the chapter 3. You can have basic derivative, you can have implicit differentiation, right? You saw me mess up on one today. You have product rule, quotient rule, all of that, right? So it could be very simple in terms of find the tangent line for x squared at point 3. Great, you can do that problem mentally, right? Because it's a 3-9 point. Derivative of x squared is 2x. Computed at 3 is 6. So y equals 6x plus b. You plug in your 3 and the 9 and you compute b. That problem you can solve mentally, right? But it could be implicit differentiation, product rule, quotient rule, or any stuff like that. Differentiation techniques. Entire chapter is teaching you how to do differentiation, right? So derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. As usually what I say to students is, if you don't know the list of basic derivatives, don't bother signing up for Calc 2 or anything like that. Because what do you think it's in Calc 2? Well, definitely not this, but uses all of it, right? So please make sure that you memorized every single basic derivative. Derivative of constant is 0. Derivative of x to the n is nx to the n minus 1. Derivative of e to the x is e to the x. Derivative of e to the ax is a e to the ax. Derivative of sine, cosine, tangent, all of these guys. Derivatives, especially derivatives of inverse tangent and inverse sine, those guys are very important. They show up in differential equations and Calc 2. When you do partial fraction decomposition in chapter 7 of Calc 2, you are going to run into inverse tangent. So you need to know these guys. The other 4, they rarely show up, right? So, but inverse sine and inverse tangent, those are the heavy hitters. Especially inverse tangent. And then product rule, quotient rule. Also look at the higher derivatives, like can you find the second derivative? Well, obviously you find the first derivative first, and then you find second derivative after that. So all of those basic ideas. Is there anything else? And then obviously we have the limit definition of the derivative for something not too crazy. We are looking at the examples that are done in class and stuff. It is not the way that you will be taking derivative ever, right? If you're a math major, well, you will be first off taking the honors section. If you're a math major, you want to be able to do limits derivatives by taking the limit. Other than that, generally, the way you find the limit is derivative is you plug it into from alpha, right? And you're done. So there's going to be a lot of that. The rates of change, derivatives is the rate of change, the last one. That's, you have a position function, you differentiate to get the velocity function, you differentiate again to get acceleration function. You have those functions in terms of variable t, which is time. Then I ask you to compute that at time equal 2 seconds. You plug 2 in each of these equations. You come up with miles per hour squared, right? Those kind of things. I would always say, straightforward. Students ask also, how about theory? Well, we don't really have, a lot of those theorems and definitions like we had before. Mainly what I can ask in this chapter, if I put up a problem together, state the formula. What's the derivative of inverse tangent? And then you just write, it's 1 over 1 plus x squared. What is the formula for product rule? F times g prime plus g times f prime, right? So that's the only stuff. There are no written formulas, written definitions like the definition of a function, continuity, and all of those theorems within continuity. We had formulas for vertical, horizontal asymptotes, like all of that stuff, right, from before. That was all. Chapter 2 was heavy on that stuff. Chapter 3 is mainly you have the formula, you either memorize it or you didn't. So if I have a theoretical question, usually I do, it would be stating formulas. But then, stating formulas, again, you have to know formulas to do all of the other problems on the test. So that's that. Do you have any questions, concerns, problems, other than implicit differentiation? Logarithmic differentiation, please remember that one is supposed to plow through anything easily if you practiced. If you haven't practiced, then obviously it's not going to go well. Yes?
Can you do a problem,
of course,
like
maybe
number 4 on the lab?
Well, did you find a similar one in the book? Because you know that I will not solve any problems that are
I know, but I just want
on the lab because it's graded material. So we can talk about the concept. I can maybe restate the problem if possible.
The problem obviously is like sine x over 8x plus 8x over sine x. I just want to know if I got the procedure right, basically.
Well, I can take a look what you did. Where is it?
Right there.
Yeah, these are 2 quotient rules.
Okay.
So you do quotient rules and then you see. So okay, you got the procedure now. Did you do the algebra? That's another question.
Yeah. Okay. If there are no questions, we can either do next lecture or
disappear into the night.
And there's not going to be any of Chapter 4 on this?
No, unless you are putting in official requests right now.
No.
You went all the way up to 311, correct?
311 is related rates. 310 was derivatives of inverse trig. One before that was logs and exponential and so that's the list for the exam. I said 10 questions. Questions, concerns? Nothing? Well, this is one boring stream now. I haven't said anything like 10 minutes. No sniffle. All right, see you.
Have a good one.
You too.
Has any questions, I guess the option is to like head out or do another lecture.
No, if you have questions, you can ask. I'll solve any of the problems. If you have nothing, we'll just... there are 13 minutes left.
Oh, okay.
I can't really teach the whole lecture in 13 minutes.
Okay.
I could have done half of it.
Can you
If
do
we started-
problem 73?
What does
Which
it...
is y equals, it's tangent lines. Find the equation.
Okay, tangent line. So we're looking for the tangent line. So TL equals question mark.
Yeah. So it's find the tangent line at each of the following curves at a given point. And 73 is y equals 3x cubed plus sine x at 0, 0.
Great.
What chapter is this one?
This is review exercise.
Review exercises. Review.
Just
At the end of the chapter.
Yeah.
All right, so we know we have to find the derivative. So y prime is 9x squared plus cosine x. Slope m is when we compute this at 0. So 9 times 0 squared plus cosine of 0. That's 0 plus 1 is 1. So slope is 1. Y equal mx plus b. Y is 0, m is 1, x is 0, plus b. So b is 0, and the tangent line is y equals x.
Now, for these problems, you can use that slope tangent equation that we learned like way in the beginning, but that would just make it way harder.
What do you mean slope then?
That f of x minus f of a over x minus a.
Oh yeah, you can use that, but that's
it's like way harder, right?
Yeah.
Okay. All right. So you can just.
That's the limit way of finding the derivative.
Okay.
That the only thing that does is finds the slope, but we now know how to find derivatives, so it's much faster.
Okay. All right.
Yeah, we don't want to bother with the f of b minus f of a anymore.
Okay.
We just want to bother with h, f of x plus h,
Okay.
to find the derivative. And then we'll use derivative to generate the slopes of the tangent line. That's much faster. Anything else? I mean, you can always stop by if you think of something, stop by, shoot an email.
The word problems that they have in the book, are those going to be as hard? Because these are a little harder.
Which are a little harder?
Well, I think this one is. Yeah, that's true. This was the example.
Problem?
Yeah, for
Yeah, that's a little bit too much.
too much. Okay. All right.
I see you next week. All right then.
Bye.
We'll say bye. Squeezed one problem.